to go through some of the skills that can be helpful for you to understand a question better. So the key three words are observe, link, and connect. Then after that, I will share with you a concept map, which we will be giving you when school reopens. And then after that, I'll go through one PSLE question. Ms. Liu will be going through the second one, and Mr. Chua will be going through the third question. Okay, so I shall begin now. Now, if you can see the PowerPoint screen, I have listed down three words here, observe, link, and connect. So these are the three keywords here that can help you to understand the question better. So what does it mean by observing? So it is not a good thing if you look at a certain science question and you jump straight to answer it. It's important for us to read the question because a lot of times in the diagrams, the tables, and the question itself, there are keywords that give you hints on how to answer the question. So it's important for you, the very first thing you need to do is to read the question, to observe the diagram, look at the table, and try to understand what is the meaning of the question. Then once you kind of understand what the question means, we have to start to link to some of the science concept we learned. So science concept can be things like heat flows from a hotter place to a colder place. Science concept can be like at a higher ground, there is more GPE. On the floor, there is no GPE. So words like this will help you to link to the question. So these are the science concept that you need to know. And of course, the last part is to connect. So sometimes we look at the question, we don't understand, we try to connect what we know in real life, some of the examples, then we connect to the question to see if it will help us to understand a certain question better. So later when I'm going through my PSLE question, I will try to use these three words to highlight to you how these three skills can help you to understand the question better and helps you to understand. Okay. So in the next slide that I'm sharing with you, this is the concept map that the school is going to provide you when school reopens. We are going to print it in worksheets. So for today's purpose, we are doing forms of energy. So using this concept map, it can help you to recall quickly what are some of the key science concepts that you need to know for this topic here. Okay. So for today's purpose, I would just like to bring you to the point of gravitational potential energy, GPE. So what we need to know about GPE is that when something is at a higher or a greater height, there is more gravitational potential energy. So the higher something is, the more GPE it has. So the next thing we need to know about GPE is that when an object has a larger mass and it is of the same height of another object of a smaller mass. So looking at this diagram here, the one with a larger mass will have more GPE. So this is the science concept we need to know about GPE. Now, when something is on the ground floor, of course, it has no way that's going to drop further. There is no GPE. So this is one of the science concepts that we want to highlight to you today in this revision session. Now, let me share with you another, the PSLE question that I will be going through. So I hope that everyone is, you have your book with you for the PSLE 3-year series. This, if you're holding on to the topical book, it will be question 5. If you're holding on to the yearly book, this question will be 2017 booklet B question 31. So I give you some time to flip over to this page before I start explaining. Okay, give me a while, there's a bit of technical error. I cannot find my H. Okay, for those who just joined us, please refer to your PSLE topical book question 5 or yearly book 2017 question, sorry again, it will be question 39. Okay, I'm going to resume now. All right, just a feedback. So someone was asking what is the link to the Padlet. So the link will be right here. The link to the Padlet to ask any question will be gg.gg/science Q&A, and today's date 2105. Okay. All right, let me continue with this question. So let's refer to this question 5. So it says that John wanted to compare how fast a wooden block can move on different planks. So this is his aim, to move to find out how fast a wooden block can move on different planks using this following setup here. Okay, so he released the block, measured the distance moved by the block down the plank, and the time taken. So as I'm reading this, I want to find out what is the thing that he's measuring, the variable that he's measuring. So he's measuring the distance. He's measuring the time taken here. Okay. So over here, what we observe is that there is a block here, a smaller wooden block on top, and it's going to go down this plank. So this plank is made of plastic. So what I'm doing right now is that I'm just observing what are the hints that's given in this diagram. Okay. Now, I continue to read the question. It says that a shorter plank made of the same material as R was placed at the same height. So now we are looking at a block moving down, released from the same height. Okay. So the question is asking, will the block take a shorter time, longer time, or the same time to reach the bottom of the plank? Now, reading a question further, it says that explain your answer in terms of energy changes. Okay, so in our mind now, what we should be thinking of is what is the science concept that is related to this question? So we are doing the linking. We have observed the question already. Now we are linking. So what I know is that I'm releasing a wooden block on top, so it has a certain GPE. So when it moves down, assuming the block will reach here, I can assume that, let's say, on the top, it has 100 units of GPE. When it moves down to the ground, it has 0 units of GPE. So this is what I'm linking back to my science concept. This question is testing me on GPE. Okay. Now, for part A over here, it talks about a second experiment setup. So let me try to attempt to draw a similar setup. So assuming the setup is the same, so it will be a block here. Okay, but we are using a shorter plank. So using a shorter plank, I will assume that it will create a steeper slope like this. Then we place a wooden block here. Now, because it is going to be released from the same height, I can also assume that this is 100 units of GPE. When it reaches the ground, we'll assume that there will be no GPE 0 units of GPE. Okay, so now I'm linking the question to the concept of GPE. Now let's think about it using real life example. If you roll something from a wooden plank in the original setup, compared to the new one with a shorter plank, which one would actually roll down faster? So think about it, something that is of a longer plank and comparing to something of a shorter plank with a steeper slope. The wooden block, which one will actually go down faster? This is by using or connecting with your real life example, real life experiences. I hope that most of us will agree that it's actually the new setup here using the shorter plank. Okay, so now, if we think that it is actually going down faster at a steeper slope, so now how do we link all this to our question, our science concept in terms of energy change? So let me try to bring attention to a rate of change. Let's say, for example, in the original setup here, okay? Let's, for simplicity's sake, we call this setup A. We call this setup B, okay? So this one, the wooden block that is going down will travel a longer distance. This one will travel a shorter distance here. So now, when we are converting 100 units of GPE to become 0 units, what is the rate of change? So the rate of change, it will be slower, okay? Now, changing to what? So when something is moving, it will have KE, kinetic energy. It will have kinetic energy here. Now, from 100 to 0 in a longer plank, the change from GPE to KE will be slower. So a slower rate of change from GPE, slower rate of change from GPE to KE means that at this point, the block has, let's say, for example, 25 units of KE. Okay, as it moves down, this will have 50 units of KE and so on. So this lesser amount of KE will mean that it will move down slower. Now, if you compare to a steeper slope, let's say, for example, here, in this steeper slope, there is the change from 100 units to 0 units at a faster rate. It will change maybe, for example, let's say it reaches here, it will already probably have maybe, let's say, 40 units, 60 units. So the change from 100 units of GPE converting to 40 units of KE, 60 units of KE, it will actually be a faster rate of change. So if we understand that the slope itself will affect the amount of KE, we can start to answer the question, okay? So to explain this, first the question is asking, will the block take a longer, shorter, or same time? We must answer this, okay? So my answer would be that it will take a shorter time. Okay, so we must answer the question. Now the next part is explain, and explain it in terms of energy change. Okay, so I would say that over here, with a shorter plank, used, the amount of GPE, okay, converted to KE will be more. Okay, so we want to compare, because now we are comparing between a longer plank and shorter plank, so we want to do this comparison. So we say that the amount of GPE converted to K will be more as compared to the longer plank. used. Okay, so what does this mean? It means that if we convert more GPE to KE over here, if we compare more GPE to KE here, more KE actually means that the block is moving at a faster rate. So this is the understanding behind moving faster. Therefore, it will take a shorter time. So if you are able to identify that using the shorter Planck, there is more GPE converted to KE as compared to a longer Planck, then it will use a shorter time. Okay. So this is the explanation for part A. Now I'll give you some time to absorb what I've explained. And if you have any further question you need me to clarify, or the rest of the teacher can help us to explain also, you can drop into the Padlet. So the Padlet webpage is this one. Okay, gg.gg/science Q&A 2105. Okay, let me pause for a while. Then after that, I'll continue with part B of the question. Okay, continuing to part B. Now, in part B, it says that John's results for Planck R are shown below. So the graph that's drawn. So it says that John repeated the experiment with a wooden plank. So now I'm just trying to understand and observe what the question is given. Then it says that the wooden block moved down the plank. This plank is referring to the wooden plank, okay, more slowly. So now in my mind, I must tell myself more slowly means that it takes a longer time. Okay, so now I continue. It says that which graph JKLM shows the correct results for the wooden plank. So let's take a look. So for the block to move down this plank R, it takes about 2 seconds. How do I read the graph over here? Okay, so the block took 2 seconds to move a distance of 80 centimeters. Now in the question, it says that the new experiment using the wooden plank, no longer plank R, is using a wooden plank now. It takes a longer time to move down the wooden plank. So what should it be? Which of the graph J, K, L, and M will represent this new experiment using a wooden plank? So if we were to take a look, so this is a bit of the math here. So over here, it says that, let's take a look. What is similar between this and this? With that graph L, if you look at the curve, it is actually similar to plank R. Okay, so this is not, graph L will definitely be out. Why is that? So because it says that in the question, it takes a longer time. Okay, so what about graph, let's say K? Over here, graph K, you can see that it takes somewhere between 1 to 2 seconds to reach this 80 cm. So we know that if it takes a shorter time, it's moving faster. So definitely this will help me to eliminate these two. Okay, so if I look at the graph again, I'll take a look. So graph M. Graph M, it actually takes a longer time. Okay, I think it is somewhere, it should be 2.4 seconds, okay, to reach 80 cm. And this actually fits the question, it takes a longer time. So for the answer for part 1 of B, the answer will be graph M. Now, in part 2 of the question, it says, besides the height h and the length of the plank, state 2 other variables. that John must keep constant for the comparison. Okay, so it says besides the height. So we cannot be talking about the height anymore. We cannot be talking about the length of plank, be it the length of plank R or length of plank of the wooden plank. So we cannot mention these two variables. So let's take a look back at what I've drawn over here. So now if I want to conduct a similar experiment, what are some of the variables that we can actually change, but we do not mention about the heights, we do not mention about the length. Okay, so some of the answer that I can currently think of is, of course, the mass of the wooden block shouldn't change. Okay, so when we are talking about, let's say, referring to the wooden block here, this wooden block, we should mention that the property of the wooden block that we don't want to change. So in this case here, if we were to write the wooden block, okay, I know that some students like to just write the wooden block. Now, this will not give you the marks. Why is that so? Because there are a lot of properties to a wooden block. Are you referring to the material? Are you referring to the mass? Are you referring to the temperature? Okay. So over here, you must be specific. Okay. So you can mention about the wooden block, but you must be specific. Tell us, what is it about the wooden block? So what I can think of, the mass of the wooden block is 1. So using the same wooden block, the same mass, you can also talk about, let's say, the material. You can talk about the surface area. So give us a property, okay, of the wooden block that you want to mention. So this is one point. Okay. Second point that I can think of is that when you release the wooden block, you should use the same amount of force. Same amount of force. Okay. Something else that I can think of, starting point. Okay. So starting point should be the same. Okay. So these are just 3 examples. Of course, there are probably more that you can actually that we can think of or discuss when we meet face to face. Okay, but these are 3 examples that I'm giving here. All right. Okay, so I've come to the end of this question. So if you have any question, we will not be doing a Q&A right now. We can do it later. But if you have some burning questions that you want to ask, go to the Padlet, drop down your question there, and we'll try to explain to you. Okay, so I'm going to move to the next question, and the next part will be explained to you by Ms. Liu. Okay, Ms. Liu.
Hello everyone, can you hear me? Yeah. Okay. For my students, it's okay if you don't have a PSLE booklet. It's okay, you can just refer to the question on the screen. Okay, so right now I'm going through question 7. It's a 2018 question, question 35. If you're using a topical one, it's on page 82. Okay, so I'll just give you a moment to flip to the correct page. If you don't have it, you can just look at the screen and start looking at the question right now. Okay, I'll start. Okay, so for question 7, Peter has a toy train that runs on batteries. He placed plates of food on the train as shown below. So when I observe the question, I see food on the table, food on the train, batteries. I see that there are batteries. I see a train moving on the track, And then if I look down closely at the question stem, right, you can see the word energy conversion. So it's actually quite clear to you that, this is a question about energy conversion already. So you link it to the concepts that you have learned. What kind of energy have you learned? You know, you have learned potential energy, electrical energy, kinetic, sound, light, heat, and so on and so forth. Okay? So applying to what you have seen in real life, this is actually quite similar to what you have at a sushi place where you have your conveyor belt on your food on a conveyor belt, right? So something similar, but not exactly the same, because this one, the train moves batteries. So with the battery, so the train actually moves by itself. Okay. So if I look at part A, when he switched on the toy train, it moved along the track. So you're supposed to fill in the boxes below to show the energy conversion as the train is moving. So the first one, okay, when I look at battery, okay, I should think of either whether a battery is an energy source or whether it's a potential energy. So because this is an energy conversion question, so it will be chemical potential energy. Okay, so you can either say chemical potential energy or you can say potential energy, but chemical energy is totally out, okay, because that's incorrect and that will not be accepted. Okay, so when I think of battery, I think of energy source or potential energy. I don't have electrical energy in the battery because the battery itself, it does not have anything unless it's connected in a closed circuit. Okay, moving on. So what comes after chemical potential energy? If I look at the word wires, okay, when I see the word wires, a few words should come to my mind, whether it's, let's say, electrical energy, electricity, or electric current. Okay, but this is a question about energy, so it should be electrical energy. Okay, I hope you're following me. Okay, because you have batteries and the circuit is closed, the electric current can flow through the wires, so you have electrical energy. And moving on, what kind of energy do you have in the train? Of course, when if everything is fitted correctly, your circuit is closed, your train is able to move. So when you talk about motion or movement, then it will be kinetic energy. Okay? Then there is the last one. Okay? Plus something. Okay? Number one, if your train moves, okay, you're most likely to hear a sound, right? When your train moves along the track, you hear a sound. So it can be sound energy. Or when your train moves along the track, okay, there is friction between the wheels of the train and the track because there's two surfaces coming into contact with each other. So you will also have friction, okay? And as a result, what happens? You will have some heat energy as well, okay? So for the second blank, okay, you can either put sound energy or heat energy, okay? And this heat energy is caused by frictional force or friction between the two surfaces of the wheels and the track. So far, so good? Okay, if everything's all right, let me move to part B. So Peter did not change the batteries. Give a reason why the train moved faster as the food was removed. Okay, so what do I understand by did not change batteries? So if the batteries are not changed, that means the amount of electrical energy remains the same. So why is it that when I remove some plates, okay, some food, the train would move faster? So let's come back to this equation, okay, not energy conversion. Okay, so let's say electrical energy remains constant. Why is it that this kinetic energy would increase? Why is it the train move faster? Okay, so when I say the train move faster, it means that there's more kinetic energy. So why is that so? Okay, it's because, okay, when I have less mass, okay, so when food was removed, it results in less mass. We know that for frictional force, one of the factors affecting frictional force is actually mass. So when there's less mass, there's also less friction. So less friction between the train and the track. Okay, so less mass, less friction between the train and the track. So what happens when there's less friction? Less of the energy is being converted to heat energy. Let me give you an example. Okay, the words I'm going to use green. Okay, so let's say electrical energy is constant. Let me give a number to it, 100. Okay, so when we know the law of conservation of energy, right? Energy is converted, not destroyed. So when it gets converted to kinetic and plus heat, okay, the number should still add up to 100. Okay, but take note, most of the electrical energy will be converted to kinetic energy. So let's say originally, without the food being removed, I have 90 units converted to kinetic energy. So my heat energy will be maybe left with 10. Okay, this is the before. But let's say after I remove some food, right? So less of the energy, there will be less heat energy. So if it's 100, this electrical energy is constant, it's still 100. Okay, more of this electrical energy will be converted to kinetic energy. Okay, so this and this should still add up to what you have over here. So in a sense that, okay, if there's less heat energy over here, more of this electrical energy can be converted to kinetic energy, causing the train to move faster. Okay, so how would I phrase my answer at the very end? Okay, so when the food was removed, the train becomes lighter. And hence, less electrical energy was converted to heat energy. So more, okay, as friction between the train and the track was reduced. Thus, let me try to move this. Thus, more energy, electrical energy is converted to kinetic energy, causing the train to move faster. Okay, there's no space. Okay, so I'll repeat. When the food was removed, the train becomes lighter and hence less electrical energy was converted to heat energy as friction between the train and track was reduced. Thus, more electrical energy was converted to kinetic energy, causing the train to move faster. So this is referring to the numbers in blue. Okay. All right. So that's part B. For part C, the concept is similar. Okay. So Peter placed a wooden block under the track at point H. So this wooden block over here, the wooden block is, the track is raised by the wooden block, so height increases. So this is the height over here, it increases. Explain why the train moved slowly as it moved from G to H. Okay, so when you increase the height over here, when you talk about height, okay, you should be connecting it to your, linking it to your gravitational potential energy. So when you increase the height over here, there is gravitational potential energy over here. GPE. Okay, so at the very start, instead of just chemical potential energy, to electrical, to kinetic, plus heat. Now you need to have some energy being converted to gravitational potential energy. So it's the same thing, I apply the law of conservation, right? So let's say if electrical energy remains at 100, let's say it remains at 100. Now this 100 units of energy has to be converted into 3 different kinds of energy. Okay, so as a result, the amount of electrical energy being converted to kinetic energy actually decreases, because some of this energy has to go over here. Okay, and that when you know that kinetic energy, the amount of kinetic energy decreases, the speed will decrease. Okay, so how will I phrase my answer? So when the block is added, some electrical energy was converted. Okay, sorry, maybe I'll change it to past tense. Was converted into gravitational potential energy. Hence, less electrical energy was converted to kinetic energy, causing the train to move slower. Okay, so you realize actually for part B and part C, the way of answering is pretty similar. Okay, it's a part of energy has to be increased, then the other one will decrease, and so on and so forth. Okay, so when the block was added, some electrical energy was converted into gravitational potential energy. Hence, less electrical energy can be converted to kinetic. With less kinetic energy, your train will move slower. Okay. Okay, so that's all from me. If any questions, same thing, please go to the Padlet. Okay, and now I will move to, I'll pass time over to Mr. Chua. Okay, thank you.
Okay, good day. I'm going to take some questions first. Is there anyone who needs to ask any question? Right, so we can maybe take a little bit of a 5 minutes break, digest the information. I'm going to go a bit slower. Any questions from anybody? You can unmute yourself and ask. Okay, before I continue. Anyone? No? No questions?
Can you write GPE in your exams?
Can we write GPE in the exam? If you cannot spell, right? If you cannot spell, else it will be good to put in GPE, gravitational potential energy. Question, next question. Just now I saw Eldon has some question, right? Eldon? Question? No? Okay, if no, right, then this is what I'm going to do. I'm going to slow down this part a little and go back to the concept map, right, as we reinforce the concept learned in the past 2 questions. Right, so let us focus our attention on this. Hold on,
I got this correct. No, I didn't get this correct. Sorry. Let me just open this for a while. Can take a look at my mind map as I get this worked out. PDF, where's my PDF? Okay, we are back. Now, so the entire gist of today's lesson focuses on this part over here, GPE, as well as potential energy, right? So we see that energy that is stored in an object is known as potential energy, and the stored energy can be formed in 3 different forms. But in today's example, we talk about GPE. We also talk about batteries, all right, where the other form of potential energy is actually our chemical potential energy. All right, so in the summary later, I will talk about it, chemical potential energy a little bit more. Now for gravitational potential energy, what is important is the very fact that due to the difference in height and the position above the ground, you'll find that if the position is higher, it has higher amount of gravitational potential energy. If it's closer to the ground, it has lesser gravitational potential energy. In the second example on the sushi conveyor belt, we learned that the amount of gravitational potential energy can also be affected by the mass of it. So if I put more sushi, it has higher mass, it means that it has more gravitational potential energy. So that's what we see in the second question. So in short, the gravitational potential energy of a particular question is affected by 1, the height, and 2, the mass. All right, so these are the 2 things that affects the gravitational potential energy, okay, in a particular question. Now, coming back to what Mr. Bo has shared earlier, he mentioned the strategy of observe, link, and connect. So where does this concept of GPE comes in? GPE comes in here. Link. We link GPE with mass. We link GPE with height. And what do we then do? We make an observation based on the pictures given, based on the words that are given. So these are the 2 things that we observe in a particular question. And then now I use words to link what? To link what we observe to the things that we have learned in science, which is GPE, affected by mass and the height. So that is what it means by to connect the ideas together. All right. So making an observation on the question, it's your step 1, and it's critical. Before you can even think about what are the things that you have learned, and whatever that you're linking to must already be learned and in your brain. So you then have retrieved this information from your brain, and finally, step 3, you connect the ideas together using what? Using words. and using useful words to link them together. Right? So in the last question for today's session, we're going to use the same strategy of observe, link, and connect to bring forth this together. Right? And with that, we're going to look at the 2019 question. 2019 question 37. Okay, topical, it will be question number 15. 2019 question, question 7. Topical, question 15. All right, for those of you without the book, all you need is to pay attention to the screen, which I'm going to share. So here you go, question number 15. So I mentioned before, what do we want to observe? We want to observe pictures and we want to observe words. And many a times, it's a good strategy to wait now, what do I do? How do I write on this? Some help. How do I write? Okay, let me open the file again. I'm going to open the file again. Physical science open-ended. Okay, should work now. All right, so I hope that as I was solving the technical issue, you're actually looking at the question, right, and making your observation. Okay, so let's start. Ziming set up the apparatus below to investigate how his toy car moved on its own along the plastic track, A down to B, up to C before leaving T. Now, C is at a fixed point above B, right? And then we have a retort stand where toy car is being released at A. So the point A tells us some idea of a GPE because it's above the ground. So the toy car has mass and it must have to do something about GPE converting to other stuff. So when Ziming released the car at A, it moved past B. So as it moves past B, energy conversion must have taken place. And what conversion are we talking about? GPE converting to move, right? So KE. But was not able to reach C. Is there any GPE at point B? Yes? No? Would anybody want to answer me? Quick one. Yes or no? And turn on and yeah, shout out the answer. Nobody. Okay, so GPE as it moves to point B, this is ground zero. So GPE is equal to 0. And then as it moves up again, energy is converted back to GPE again because there's a height involved. And was not able to reach E. Explain why. So I have shown you the mind map on GPE, telling you that GPE has to do with mass. Toy car don't change in size and weight, and the size of it, so the mass remain the same, right? The height is fixed, so there's some height element. But in the previous question explained by Mr. Bo and Ms. Liu, we noticed that when there is a movement along something, any movement along a surface results in friction. And that's what Ms. Liu has mentioned in the previous question. And from friction, what kind of energy is then produced? Friction is related to heat energy. So as the toy car moves from A to point B, there must be some form of heat energy being generated or converted. So why was the car not able to reach C? So as the car moves from A to B, what happens? Some energy, okay, is converted to heat energy. Now, you notice that I wrote here some energy. What kind of energy is converted to heat energy? Is it potential energy or is it kinetic energy? Okay, notice the starting point is A, so some potential energy is converted to heat energy instead of kinetic energy. All right, and hence the remaining energy is not enough to convert to GPE to reach point C. So some energy is being converted to heat energy, and hence the amount of energy left is not enough to convert back to GPE to reach the point C.
Mr. Chua,
Yes.
what is the word after the B?
What is the word after?
The B in the first sentence.
Some potential energy. All right. Now, in the previous lesson, if you have attended my lesson, you notice that I like to use the word some and all in certain question to bring across the idea that actually a certain amount of energy is being wasted. Okay, so the word some comes in very useful. Okay, to link some of this idea together. So that's what we observe, and then energy conversion from potential to heat energy, that is what we think, and then we connect it with using words like this: some, remaining energy, not enough to convert back to GPE. Okay, so that's the first question. Part B, without using different apparatus and additional materials, without using different apparatus, so we're not going to change and say that, oh, we're going to change to a bigger car and things like that. We're not going to say that, oh, we're going to add one more RAM, another piece of RAM, add a spring. We can't change all this. Suggest two different ways to help the car to reach C. Explain your answer. So I remember when I was marking this particular year, there were students who left out on explanation. Okay, so do read each question stem carefully. So we definitely want to increase the amount of GPE. With more GPE, definitely we are going to be able to move the car faster and over a longer distance. So what can we do? We can, one, raise the ramp or track above A. So we're going to raise the starting point because the starting point is where our GPE is. Raise it above A. All right. And what's the reason? To increase the amount of gravitational potential. I'm going to write this to save space at the start, so that more GPE is converted to more KE. So when there is more GPE converting to more KE, the car will then be able to move all the way up to point number C. What about the second idea? So we have moved it higher. The other possibility is we want it to move, right? And we cannot change any equipment. We cannot say that I'll move point C lower. So the other one would be we must use more force or energy when releasing the car. So when we use more force or energy when we release the car, same thing, with more force and more energy, more energy will be converted to what? More energy will be converted to more KE. And same thing with more KE, the car can then move to point C. All right. Finally, state the main forms of energy that the car will have at point C. So we go back and observe again. At point C, the car will be above a certain height. At point C, the car must still be moving, right? So state the main forms of energy, kinetic energy, and potential energy. And I would like to ask a question. Is there heat energy? Yes. Or no? Would there be anyone who would like to answer this question? Is there any heat energy at point number C? Yes or no? Anybody?
Yes.
Yes, Arush, why? Yes.
There is a frictional force between the tires of the car and the track.
There's frictional force between the tires of the car and the track. But is there any movement at point C? Is there any motion at point C?
Yes, while moving down towards
When
the end
you
of the
move
track.
down, is it at point C? All right. So I think the whole idea that I asked this question here is to get you thinking about this idea of at point C. Is there any motion? If we say that there is motion, then it must be from point C onwards. Right? So if there
I
are
didn't
no
read the
motion,
question there.
right? So if there's no motion at the point C, then we are not going to include heat energy in this answer. Okay, because at point C, there's friction. Yes, the friction between the tires and the track, there will be some form of contact friction. All right, but at point C, there is no motion, so heat is not produced, and therefore we are not including heat energy for point C. Okay, with this in mind, to summarize the entire session, we spoke about observing the question, linking it to the concept, and mainly the main thing we talk about is GPE. Of course, we also spoke about a particular type of energy called chemical potential energy, which are found mainly in the batteries. That's question number 2. All right, and with batteries, chemical potential energy can then be converted to electrical energy in the wires. Okay. Lastly, we learn how to connect by using words such as some potential energy is being converted. And you notice that we use the word converted in most questions, all right, and not transfer and not become, but converted. All right. And then the other important concept that we have learned is the existence of heat energy. And we say that when things are moving, as it moves, there will be friction between the surface. That's what Ms. Liu mentioned. And then with friction, there must be some form of heat energy. And that's what Mr. Bo has mentioned in the first question as well. Okay, heat energy. And then we have GPE and CPE, chemical potential energy. And then last but not least, any movement result in some form of kinetic energy being converted. Okay, and with that, do you want to take the Padlet questions? Okay, with that, Mr. Bo will take some of the questions that are on the Padlet before we end off the entire session. All right, over to you.
Okay, Mr. Bo here. So there are some questions that are posted on the Padlet. So if you have further questions after this, you can continue to post over here. So the first question is by Arush. He's asking, is forces in PSLE this year? So yes, forces will be tested in PSLE this year. What is not tested will be interactions with the environment. Okay. Next question is asked by Chloe Kwan. Okay, so she asked, what is a fair test? So a fair test essentially is asking about an experiment, and we keep all the variables constant except for what we are trying to find out here. So I give you an example that let's say for this one, I mentioned that if you want to find out whether the types of surface will affect how far a ball can roll. So what we are trying to find out is the type of surface affecting the distance. So the variable of types of surface we change. While the rest, for example, the mass of the ball, the type of the ball, we keep it the same. So if we conduct an experiment like this, it will be a fair test. Next question asked by Hui En. She said, why is same force taken as the answer? So I mentioned that, okay, actually I should be a bit specific here. So let me share with you my edited answer. Okay, so actually when we say the same force, we are referring to using the same force when releasing the wooden block. Okay, so please add on to the next part because this will make the answer more specific. Okay. So this is my clarification for Hui En's question. And these are the 3 questions that are being asked in Padlet. So as I mentioned, if you have more questions, you can continue to post it here. Okay. All right. So I'm going to pass the mic back to Mr. Chua.
All right, we have some instructions for all students here. Right. So SLS and Zoom works in tandem, meaning both of this happen at the same time. So in about half an hour after this lesson, we will be assigning you, looking at the correct screen, yes, we'll be assigning you an SLS package. Now in the SLS package, it has some MCQ questions on all questions related to energy conversion from 2017 to 2019. Okay, you can answer the question and then the solutions and explanations are already keyed in. Now on top of that, you will get to see question number 39, which is explained by Mr. Bo. Question number 35, the sushi one by Ms. Liu. And then the last question, which is by me. So all these 3 questions there are for you to, once again, type out your answer and for the teachers to take a look at the solutions. Now, we will recommend and encourage you to relook at the question again and type in the answers accordingly, rather than just merely copying from whatever that was mentioned in the lesson. Okay, so this will be assigned to you. about half an hour after this session, and we hope that you can then try out the questions, and then for us to know if you have had understood the lesson properly. Okay, if not, then that's the end for today. Those of you in my class or whoever is here, if you're interested in more web lessons for math tomorrow, you can catch me at 1:30. Okay, you can catch me at 1:30. Check with the students in primary 6-5, they will be able to give you the password, okay, and the login ID. Okay, till then, see you again. Have a good weekend. Bye-bye.